Guten Morgen, JS Conf EU. So today, as Anouk said, I'm going to talk about things that I think I know what you're talking about, but I'm not quite sure. So I'm Jen. I'm a front-end developer. I am currently a software engineer at Eventbrite, as Anouk said. And you may know me as the creator of Human Wasteland, also known as the Poop Map, particularly those of you from the Bay Area. You may also know me as the creator of Developers, which is a project I recently created as a dedication to Mr. Steve Ballmer. But all of that is just a long-winded way of saying that I write code for a living. Before we get started, some quick disclaimers. There are going to be a lot of animated GIFs in this talk, and there may be a few errors. So if you notice any of those errors, before you start to feel a little bit like this, or a little bit like this, let's talk about it, but come and find me after my talk. So let's go. As I said, I'm a developer, software engineer, programmer, or whatever else you might want to call me. So some days when I look at my computer, this is how I feel. And I'm pretty sure many of you could relate to that feeling. And sometimes when I'm in conversation with other developers, I feel like this. So Phil Carlson once said, there are only two hard things in computer science: cache invalidation and naming things. And we can see that in the many various complicated terms in computer science and web development. So here is just a general sampling of some of the words I've come across in my career as a programmer. And oftentimes I hear them and I'm like, they're a little bit familiar. I think I know what you're talking about, but I'm not really sure. And so in those conversations, I often ask people, can you explain that word to me? And in doing so, I get a look like this. And when I get that look from other people, it makes me feel like this. So again, these words are very complicated. They have very checkered pasts. They have very interesting history. They come from all different places. And so today I'm going to go over a few of those terms. So when you hear them in conversation, perhaps you'll feel a little bit less like this, and you'll feel a little bit more like this. Yeah, Brent Rambo. All right, so first up is parameter versus argument. What's the difference? Is there one? So to find out, I of course went to Google. And when I search parameter argument, you'll see many people are wondering about the difference between the two, because you can see it's the third query down that's autofilled. So here I've written a function. It's called shark. And I call shark at the very bottom with the string left. So how many people in the audience think that the parameter is in that first line, side? Raise your hand. And how many people think it is the string left in the bottom line of this code? Raise your hand. And obviously I'm raising my hand both times, so you guys don't know. All right, well, I'm not going to tell you, but I'm going to keep going. So parameter in the online etymology dictionary, and etymology is essentially the history of words, says that parameter is a measurable factor which helps to define a particular system. And when I read that, I'm like, oh, okay, I think I know which one is the parameter now. But I keep going, and when I search argument on the online etymology dictionary, I find that there's just information about people arguing with each other. So I'm like, well, that doesn't explain to me what an argument is then. So I keep going, and I check out computer programming on Wikipedia. And here I see that the term parameter, sometimes called the formal parameter, is often used to refer to the variable as found in the function definition. while argument, sometimes called the actual parameter, refers to the actual input passed. And because I'm a developer, I'm like, oh, okay, this definition makes sense to me. But I wonder, why didn't we stick with the terms formal parameter and actual parameter? And to find that out, we've got to go down the rabbit hole. So I look up mathematics. I search parameter and argument in mathematics on Wikipedia, and I find that a function definition can also contain parameters. But unlike variables, parameters are not listed among the arguments that the function takes. And I'm like, what does that mean, Wikipedia? Like, please go on. So we see here that the variable x designates the function's argument. But a, b, and c are the parameters. So I look at this quadratic function, and I see that x is the argument, and a, b, and c are the parameters. And I was like, wait a second. So I have a math function up on top, and we see that a is the parameter. Then I have a computer science, or a function in JavaScript, and I see that bar is the parameter. I'm like, whoa, that's totally messing me up right now. So the way I explain it is that this bulldog is a parameter, computer science is the football, and so as soon as a parameter hits computer science, its definition just gets flipped completely on its end. So the takeaway here for me is actually that parameters help define a function, and arguments are passed into a function, but that's only in computer science. So here's our answer. The parameter is up on top in Shark, in the function definition, and then the argument is down at the bottom, that string left in the function call. And all of that being said, we just use parameter and argument interchangeably anyways. So that was easy, right? All right, next up is scope. So I don't know about all of you, but when somebody asks me to talk about scope, I'm like, I don't want to talk about scope. Please don't make me talk about scope. But I'm going to talk about it today. So first up is lexical scoping. And of course, I go back to Google, and I see that lexical scoping, parentheses, sometimes known as static scoping, is a convention used with many programming languages that sets the scope, or range of functionality, of a variable so that it may only be called or referenced from within the block of code in which it is defined. So that definition has 3 different equivalent definitions just within it. So they say that lexical scoping is equivalent to static scoping, scope is related to, or is equivalent to range of functionality, and called is equivalent to referenced. Worst of all is they actually use the term scope in the definition of lexical scoping. So let's break it down a little bit. Scope in the online etymology dictionary is an aim, purpose, object, thing aimed at, mark or target. And I'm like, that doesn't really explain it in computer science for me. So let's keep going. So I search scope on Wikipedia, and I see that a scope is a part of a program that is or can be the scope for a set of bindings. A precise definition is tricky. See below. Okay, thanks a lot, Wikipedia. I guess I'll see below. So below I see that in computer programming, the scope of a name binding, an association of a name to an entity, such as a variable, is a part of a computer program where the binding is valid, where the name can be used to refer to the entity. And I'm like, well, that makes sense to me because I know what scope is already. But somebody who's new to programming may come and read this and be like, I don't really know what you're talking about. And so when I read this, I'm like, it's an okay definition. So I keep going, same article on scope in Wikipedia, and then they say, the strict definition of lexical scope of a name or identifier is unambiguous. I'm like, thanks a lot, Wikipedia. You're so condescending. It's unambiguous. But it says that it is, quote, the portion of source code in which a binding of a name with an entity applies. And I'm like, okay, that makes sense to me. It's pretty short and sweet. And I keep reading, and I see that it has been virtually unchanged from its 1960 definition in the specification of ALGOL 60. And I don't know about y'all, but when I saw ALGOL 60, I was like, I don't know what that is. So ALGOL 60 is short for Algorithmic Language of 1960. And ALGOL 60 was the first language implementing nested function definitions with lexical scope. And I was like, wait, so we've had the definition of lexical scope since 1960, and it's still so hard to explain to other people. But moving on. So let's talk about lexical versus dynamic scope. So lexical scope is the main focus of that Wikipedia article, with dynamic scope understood by contrast with lexical scope. So I read this and I'm like, really? Like, I have to know what lexical scope is first before you can even define dynamic scope for me? Ugh. All right, so let's get a little bit deeper. So lexical, on the online etymology dictionary, means pertaining to words. And I'm like, huh? Okay. What about dynamic? And dynamic means pertaining to force-producing motion or the opposite of static. And I was like, oh, that's pretty interesting, because that first definition of lexical scoping on Google said that lexical scoping is also static scoping. So I keep going and look up more about scope on Wikipedia again. And for most programming languages, part of a program refers to a portion of the source code or area of text and is known as lexical scope. I'm like, oh, okay, that's where pertaining to words comes from. And then in some languages, however, part of a program refers to the, quote, portion of runtime or time period during execution, and that's known as dynamic scope. And then I keep reading below, and I see both of these terms are somewhat misleading. And I'm like, oh. And I keep reading, they misuse technical terms as discussed in the definition. And I'm like, oh, so what I just read is wrong? And then I keep reading and it says, but the distinction itself is accurate and precise, and these are the standard respective terms. And I'm like, oh, so what I just read was right. Okay. So I keep reading, again, of course, and we see that in practice with lexical scope, a variable's definition is resolved by searching its containing block or function, then if that fails, searching the outer containing block, and so on. Whereas with dynamic scope, the calling function is searched, then the function which called that calling function, and so on. And I'm like, oh, that's pretty clear. I think that makes sense to me. So all that being said, this is a JavaScript conference, so who cares about dynamic scope? So the way I like to think about lexical scope is the box is a function, the orange cat is a variable in that function. The orange cat can see the white cat, but the white cat can't see the orange cat. Okay, next up is recursion. So recursion on the online etymology dictionary refers to a running backwards, or to return, or to run back. And I'm like, oh, that kind of makes sense, but not quite related to computer science. So I look up recursion on Wikipedia, and I read that the most common application of recursion is in mathematics and computer science, in which it refers to a method of defining functions in which the function being defined is applied within its own definition. And I was like, wait, I thought this was a definition. Why are we defining so many different definitions within its definition? So I keep reading, and I see that specifically, this defines an infinite number of instances, or function values, using a finite expression that for some instances may refer to other instances, and in such a way that no loop or infinite chain of references can occur. Let's keep going. So I keep reading down this article, and I see that in mathematics and computer science, a class of objects or methods exhibit recursive behavior when they can be defined by two properties. Number one, a simple base case or cases, a terminating scenario that does not use recursion to produce an answer. And number two, a set of rules that reduce all other cases toward that base case. And again, that kind of makes sense to me because I am a developer, but for somebody who's new, they probably are going to give me a look like this when they read that. So at its base, I like to describe recursion as a function that calls itself. That's what I would like to see on Wikipedia instead. So oftentimes people will explain recursion to other people by saying this, and then they decide to get a little bit more complicated and talk about the Fibonacci sequence. And I'm like, oh God, I took math like over a decade ago. I don't know about y'all, but I see this and I'm like, I don't even remember what the Fibonacci sequence is. So when somebody starts to explain recursion to me by talking about the Fibonacci sequence, I'm like, whatever. One time, though, a friend explained to me recursion by talking about factorials. And I think everybody really likes factorials because they have this cute little exclamation point. And if you remember them from more like elementary or middle school mathematics, I'm like, oh, that makes a lot more sense. And I really like that definition of recursion. So when somebody talks about that, I feel a lot more like this. Like, yeah, that's a good example. All right, next is concatenation. So concatenation on the online etymology dictionary refers to a linking together, to link together a chain. And I was like, whoa, we actually use that word correctly in computer science. Go us. But really the true reason I want to bring up this word is because it's got cat in it. And this is my cat. Everything's better concat. And here's a recursive cat. It's stuck in that infinite loop of a function. I don't know. Okay. Anyways, next up is instantiate. So instantiate, from the online etymology dictionary, it comes from instant, and it was created in 1946. And I'm like, oh, that's pretty recent, actually. And then I go to Google, and I'm like, what does instantiate mean? And it means to represent as or by an instance. And their example is a study of two groups who seem to instantiate productive aspects of this. This what? As if this wasn't confusing enough in JavaScript. So in Wikipedia, when I search instantiation, I actually come across philosophy. And it says that in predicate logic, universal instantiation, also known as UI, also called universal specification or universal elimination, and sometimes confused with dictum de omni, is a valid rule of inference from a truth about each member of a class of individuals to the truth about a particular individual of that class. And I was like, okay, that kind of makes sense. But basically, all cats are mammals, Fry is a cat, and therefore Fry is a mammal. So that's universal instantiation in philosophy. So here I have a class that I've created called mammal, and a class that I've called cat, and I set the cat's prototype to mammal, and instantiate a new cat here called Fry cat. So basically, Fry is a cat, all cats are mammals, and so therefore Fry cat is also a mammal. I was like, cool. Another good thing that we have correct in computer science, instantiation. But weirdly, the online etymology dictionary, instantiation actually redirects to instantiate, and on Wikipedia, instantiate redirects to instantiation. So we only have either the noun form or the verb form. You can't have both, apparently. Anyways, moving on to acronyms. So here are some acronyms I always get confused. CRM, CMS, and CDN. And just to go over them again, because they're very confusing, CRM is a customer relationship manager, kind of like Salesforce. A CMS is a content management system. It's kind of like WordPress. And a CDN is a content delivery network, kind of like Amazon CloudFront. Next is SaaS versus SaaS. When you're talking about SaaS, please clarify to me which one you are talking about. Are you talking about software as a service, like Salesforce, or are you talking about syntactically awesome style sheets, which is the CSS extension language? I don't know, but if you don't tell me, then I'm going to get sassy about it. Next is DOM. So there are many kinds of DOM. This is Grazer DOM, which is a chapel in Austria. This is DOM, the indie rock band. And this is the DOM, which is a mountain located in the Alps. And again, we see that word SaaS. So there are many kinds of DOM. But the DOM that we're interested in is the document object model. Wikipedia says that the DOM is a cross-platform and language-independent convention for representing and interacting with objects in HTML, XHTML, and XML documents. I'm like, oh, it kind of makes sense to me. Let's keep looking for another definition. So I search Mozilla Developers Network, and I see that the DOM is a programming interface for HTML, XML, and SVG documents. It provides a structure representation of the document, a tree, and it defines a way that the structure can be accessed from programs so that they can change the document structure, style, and content. And I go, okay, that makes a little bit more sense to me. Thanks, MDN. Best of all, they actually have an illustration of the tree. And I'm like, oh, that's the DOM. That's what it looks like. Cool. All right, next is GUI and CLI. So I like to call CLI CLI, because if we call it GUI, why can't we call it CLI? So when I hear GUI, I think of ooey gooey butter cake, and then I just can't work anymore. I also think about gooey ducks. I'm not sure if y'all know what that is, but it's basically a weird bivalve that lives in the ocean. It's also edible, kind of tasty little things. But strangely, this is actually how you spell gooey duck. Kind of counterintuitive. And then when I read CLI, I read it as Klee again, and that makes me think about Paul Klee, the painter. But most of us, I think, really know that GUIs are graphical user interfaces, and they were first introduced in reaction to the perceived steep learning curve of command line interfaces, or CLIs, as I like to call them, which require commands to be typed on the keyboard. And lastly, I have AJAX. I love the word AJAX, but it's really outdated, because who even uses XML? I also found out recently that the jQuery AJAX method has an option to set async to false. So that means that you can actually be running sjaj. All right, in conclusion, so oftentimes when we hear these terms, we're like, I have no idea what you're talking about. And as soon as you understand it, you just get it. And because you just get it, it makes it really hard to explain those terms to somebody else. You kind of have to wait for them, and you kind of have to nudge them until that light bulb just hits. So I know it's really difficult to explain to other people, but I implore you, when somebody asks you to explain a term, try not to be like this. Or like this, you're trying to pass the buck to make somebody else explain it because you don't feel like it. And try to please be a little bit more like this. Because it's really difficult. It's so hard to understand. And let's watch this video. So we see here, number 12 has just fallen on the ice, and she's like, I don't understand what GUI is. Everyone around me is talking about GUI. They're all talking about GUI, and I don't know what it means. Another number 12 is like, let me help you. I'm going to explain GUI to you. GUI, it's just the graphical user interface. And other number 12 is like, I understand. Thank you. So when we're all a little bit more like these number 12s, then we can party together in the computer science jargon land. Thanks so much.